The moon is going around the earth. How many knew that already? The moon goes around the earth. Okay? Did you know as the moon goes around, it's gradually getting farther away? We're slowly losing the moon. It's only a couple inches a year, about 3 inches a year, so it's no big deal, nothing to worry about. Plus, there's nothing you could do about it anyway, okay? But the moon is getting farther from the earth every year. Now, kids, this is going to be complicated, so listen carefully. The moon is getting farther from the earth every year. So that means that it used to be closer. How many can figure this out? Now, stay with me, okay? All right. Well, if you bring the moon in closer, you start to create a problem because the moon causes the tides. Now, you folks in Jacksonville probably have to worry about the tides, don't you? If a hurricane hits during high tide, you got a serious problem on your hand. Well, if you brought the moon in closer, the tides would be higher because of a law known as the inverse square law. If you brought the moon into 1/3 the distance, you take the 1/3, inverse it, and square it, it's 9 times the gravitational pull. And if you run all the math on this, you'll find out about 1.2 billion years ago, the moon was whizzing around just above the surface of the earth. Now, way before that, you're going to have a serious tide problem.
I'm going to let my good friend Thunderfoot explain this to you.
Now, the Earth has water on its surface, and this deformable matter is distorted by the gravitational field of the Moon to give 2 bulges. However, the Earth spins so quickly compared to the orbit of the Moon that these bulges are distorted and pulled ahead by the rotation of the Earth. This is why the tides on Earth always lag the Moon passing overhead by a couple of hours. However, this gives the Earth a peculiar shape, which has the effect of accelerating the Moon at the cost of slowing down the rotation of the Earth. The transfer of energy to the Moon moves it into a higher orbit. It gains potential energy, which perversely has the effect of making the Moon orbit more slowly. Oh yes, even simple orbital mechanics can be a mind-bender. It seems reasonable to suggest that the current state of the continents, forming essentially 2 land bars around the Earth, may be particularly apt for this transfer of energy from the Earth's spin to the Moon's orbit. However, this is not how the water on Earth and the continents have always been arranged. Measuring the current rate of lunar recession is comparatively easy to attempting to calculate what the rate of lunar recession was in prehistory. Although those who have attempted such calculations estimate that in Pangea times the rate of lunar recession may only have been half of what it currently is.
Through space, but comets are constantly losing material. That's what the tail is blowing off of a comet. It's losing part of itself, okay? You can't just keep losing and losing. Pretty soon, it's gone. You know, it's kind of like your checkbook. See, if your outgo exceeds your income, your upkeep will be your downfall every single time. Well, these comets are losing material, and it's been estimated they can't last more than about 10,000 years. Okay, well then I have a question. If the Earth is billions of years old, and if the universe is billions of years old, why do we still have comets?
Why do we still have comets? Well, comets are asteroids. When they're zooming through space, that's how fast they go that they burn up. Okay? So, if there's an impact, a bunch of comets are released, let's say there's this giant, let's say there are 2 asteroids, they just crash, a bunch of sparks fly out, and they're comets, so they're released, and that's how these comets are made. And see, asteroids hit each other all the time, and there's asteroids from other places in the universe. Maybe even other galaxies that come in. I don't know.
Those who don't know what an astronomical unit is, that is the distance from the Earth to the Sun. That is 1 astronomical unit, 93 million miles.
Actually, no, Kent. It's not exactly 93 million miles. It's about 92.55 million miles. That's closer. You know, maybe you did some calculations with this, I don't know. But it's wrong. Because maybe if you did do some calculations with that, your calculations are wrong because you're wrong about that.
Comet argument, it's up to you to prove beyond a reasonable doubt that the Oort cloud and other sources don't exist. He's saying, I got to prove the Oort cloud doesn't exist. Now just hold on a minute, Dave. That's not the way science works. What he's trying to do here is called shifting the burden of proof. The liberals are really good at doing that, and we fall for it most of the time.
Really, Kent, you want to talk to me about the burden of proof. You're saying that the burden of proof is on the people who are making the claim, but yet you want atheists and other non-believers to disprove the God, or to disprove something. And you mentioned later in the video, and I did cut it out of this video, but you did mention that how can you disprove the existence of something? That is what I'm trying to get at. You're essentially making the burden of proof onto you. Not me. It's all you. That's what you're doing here. So if you're Christian and you're watching this and you're a younger creationist like Kent Hovind, and you've watched Kent's videos and you for some reason agree with them, let me ask you something. Why do you always ask me to disprove God when Kent here just made the burden of proof on himself? So the rationales.